Quite some time ago I posted a number of videos on the repair of some Intel MDS units that I'm working my way through. I had a number of these units to repair. If you're not familiar with them, they're very large, complex development systems that were built by Intel quite some time ago for really developing their processor-based systems. Now, the systems themselves are very large, so they have a huge power supply, and this is the power supply out of one of them. And when I posted the original videos, I showed testing these using some Kunkin electronic loads, and I leave them on test for quite a long time. And I do this quite a lot. When I'm testing things, I do tend to test them fairly thoroughly. And I have been asked a few times why I go to all the time and trouble of soak testing units like this that have been around for a long time. If they were going to fail, then they would have done. That's not really true. These units have been sitting around for an unknown length of time. Electronic components degrade whether they're in use or not. And so quite often what you will find is when you power a unit up that's not being used for a long time, initially it might work fine, but over a few hours or a few days you might suddenly start getting failures. And with a power supply like this, coupled to very complex electronics, you do need to be fairly careful. And so I've been working my way through the MDS units, working on the chassis, on the electronics, and while I've been doing that, I've been soak testing the power supplies, cleaning them, working my way through them, and making any repairs that I needed to. I haven't been posting videos on that. It's fairly tedious work, so it's quite repetitive, and I didn't want to just make videos of the same thing over and over again. I'm sure you wouldn't find that interesting. However, this particular power supply had quite an interesting fault, so I thought I'd make a quick video and explain what it was doing and what I found. So I'll just get this out of the way. So as you can see, I have dismantled this. One of the issues working on these, they're a bit of a pain, is to get some components out. You do need to completely dismantle them and desolder quite a few components to get to the one you need to replace. Now this unit, when I was testing it, again I was testing it with the electronic loads. It wasn't plugged into the MDS unit, which is perhaps as well. Initially it was running fine, and these units have multiple rails, all fairly high current, but the 5-volt rail can put out a continuous 30 amps. In fact, it will put out near a 40 or 45 amps. It is supposed to be crowbar protected. And what I mean by that, I'll just grab the schematic. So if we look at the schematic for this, this is the 5-volt part of this unit. You've got various modules, and this is for the 5-volt module that sits on the back. We can't see it at the moment. But at the bottom we see this component here, and this is crowbar protection. The idea is that if the voltage coming out of the 5-volt rail goes too high, then it's sensed, it triggers this, and it effectively short circuits the output. That puts it into current protect mode, and the other current will shut it down, and it will stay in that mode until you cycle the power. And this wasn't happening. When I was monitoring the voltage, it was fine. Initially, it was just over 5 volts, but the voltage started to creep up fairly quickly. It was going up by maybe half a volt a minute, and it got up to about 9.5 volts, which is way beyond what should have caused it to shut itself down. And it was continuing to rise. So the electronic load was pulling a lot of power at that point. We'd gone way beyond the rated power output because we were drawing up near 25 amps, and it was putting out nearly 9 volts. So I shut it off, recycled the power, and tried again, and it did exactly the same thing. I did test this device separately, and it worked. So there's something strange going on. It wasn't triggering the other voltage protection. Now, of course, had this been plugged into the MDS unit, initially it would have worked, and this failure started maybe 2 days into the soak testing. So the MDS unit would have worked, but ultimately it would have been completely destroyed, putting 9 or 10 volts, or probably more if it just carried on rising, at 30 or 40 amps through 5 volt electronics is it's always going to cause quite a lot of damage. But it was a very strange mode of failure. So initially I thought we had a bad transistor, and one had gone short, collector emitter, but that should have triggered the other voltage, the other current shutdown. And in theory it wouldn't have been able to shut it down, of course, because if it was short it would have carried on driving current, but it should have blown the fuse, and it didn't do that. So something weird was going on, and it was in this circuit somewhere. So what I did is I removed the module. So this is the 5 volt module, so that's this module out of this unit. And as you can see, it's a real pain to get to. There's a lot of very heavy duty wires you have to unbolt, and then you have to desolder all the transistors on this, and that's the only way you can get the board out. So once I've done that, incidentally, this protection device is this device over here, a very big beefy thing, so that's working fine. But after desoldering this, I flip this over and we've got a broken track. So the broken track though is in the protection side of the system, so I'm not quite sure exactly what's going on here. I'm assuming at some point there's been a short somewhere. But when I started looking into this and making some measurements, it became clear what had happened. So I'll just get the test meter. Okay, so hopefully you can see the meter. So we have 4 transistors on this. One's a 2N3055. Let's have a quick look at the circuit. So we've got a 2N3055. That's actually been used as a driver for the other 3 pass transistors, which are 2N3771s. Fairly similar devices actually. You probably could substitute the 3771s with 3055s, but I always replace them like for like, just to make sure it's going to behave the way it was intended. But they're all NPN transistors, and they're all in the same package. So if we start trying to test these, we'll start with the 2N3055. Probably familiar with testing these using a multimeter. So we should find it acts like a couple of diodes. So from the base to the collector and the emitter, in one direction we get nothing, and the other way around we should see it as a diode. So we've got a diode to the collector, diode to the emitter, and that works fine. Between the emitter and collector we should have nothing, so again that's fine. But when we start looking at the 3771s, again same pin out, so it should do the same thing. So this one has got a partial base to collector short, but is otherwise open. This one is doing kind of nothing at all, and this one has got a dead short between the base and the collector, and nothing much happening between the base and the emitter. So this is what caused the track to blow out. It's connected between the base and the supply rail, and so it's burnt through the track, and because the track was open, the protection circuit was effectively disconnected, burnt through, and obviously the crowbar protection was doing nothing. It couldn't do anything because it wasn't connected to the 5 volt rail, and the rise in voltage was caused by the various shorts and the odd behaviour of the pass transistors. So all 3 of the pass transistors seem to have failed, but in different ways. The 2N3055 driver seems fine, but I'll be replacing all 4. Because it's such a pain getting these apart, there's no real value in just replacing 1 or 2. If one's failed, then the rest are going to follow fairly soon anyway. Okay, so that's the mode of failure. I'll get these replaced, get it reassembled, repair the track, reassemble the power supply, and put it back on test. But I thought I'd show this. It's quite an interesting failure, and the sort of thing that we find when we do soak testing, and that's why I run them for so long, just to make sure that it does this with the supply out of the unit. We definitely do not want it doing this when it's plugged into the MDS.